All right, so we're going to do 5.3 today, which is called Properties of Logs. Tomorrow we're going to do solving log and exponential equations, and then that's going to be the end of the content that will be on your test. Remember, we're doing it in 2 parts. So like Wednesday, Thursday, we'll review for Friday's part, and Friday's the calculator portion, which means you're going to get a little bit of the interest problems. You're going to get a little bit of what we do tomorrow, really, is heavy calculator, which is the solving the expressions and that kind of stuff. Anything involving like E, that would be on the calculator part, which is Friday. And then the following, the following Wednesday will be the second part of your test, and that's going to be like your graphing, and then a lot of like what's on today's stuff, like you need these properties to use tomorrow's stuff, like everything kind of leads into it. But you're gonna you'll see there's stuff without a calculator, there's stuff with a calculator. All the log stuff, like so if I had like log base 5 of 25, something like that would be on the non-calculator part. Something where you have to change the 2 bases to be the same, and then you set the exponents, all the one-to-one property, all that's non-calculator part, so that's next Wednesday. But those things also have calculator components in it. So, I mean, the good thing is we're going to kind of weave in, like, while we're doing it, you're practicing what's on next week's as well. But today's would be not, like, mostly non-calculator stuff. And it's called Properties of Logs. So we're taking our logs, right? So hopefully we remember, like the short mental math part of the logs. So you could get something like log, like what's the one I said, but base 5 of 25. And on the video, I said, you could set this equal to X. Like I could say this equals X if it doesn't already have it. Most of those already had it. And then I could convert this into exponential. The 5 would come over and pick up the X equals 25. And then you're saying, what do I have to raise 5 to get to 25? So the answer here would be what? 2. The goal, however, would be to get so comfortable with logs that you could look at this and know it's 2 without having to go through that process. That's when the mental math really pays off, right? So you're looking at the base and the log. You're saying, what do I have to raise that to get to the large number? So 5 to the second is 25, and that's why this answer is 2. So, like, the more comfortable you are with logs, the easier everything else is going to be from here on out. So this is called change of base, and this is what you can do if the log is not log base 10 or log base E, and it wants you to find the value. So this could be like log base 2 of 3, something in which I can't raise 2 to a power to get 3. Then we use this, which is called change of base. So whatever the number on the bottom, right, the base is on the log, I find the log of that over the log of the larger number here. And because the log base can be the same and it can be any number, I can actually use the calculator to do log of X over log of A. And then one step further, because the log base can be anything as long as they're the same, I can change it to log base E of X and log base E of A, and that's the same thing as doing ln. So remember, log by itself is the same as log base 10, and ln is the same thing as log base E. So if I look at it with actual numbers, this is log base 3 of 23. So the 3, the little one, the base goes in the bottom. So I do log of 23 over log of 3. Or I can do ln of 23 over ln of 3. And then if you actually use your calculator, you'll find that that rounds to 2.85. So I would do ln of 23. If you want to practice so you remember to start to close the parentheses, you can take out your calculators. I would do log of 23. You have to close the parentheses, or ln of 23, close them, and then divided by ln of 3. Or you could do that in 2 separate steps. I get 2.854, which rounds to 2.85. So we do log of the bigger one over log of the base. Now that doesn't mean bigger as in the value. It's bigger as in like the physical size that you write it in, like the one that we write larger. Base goes in the bottom, so just remember base bottom. So if my question, let's say it said log of 25, I wouldn't need to do change of base because I can use the log button on my calculator. That is log base 10, okay? If it said ln of 25, I wouldn't need to use change of base. I could use the calculator because my calculator has those buttons. So we're talking scenarios in which the base is not 10 or E. That's when you do change of base.
So we put into the calculator, put
Correct. Yep. So if it's ln, which would be log base e, 25, then you have to use the regular ln button. Yep. But you don't need to use change of base on those. Those you're just typing in. Change of base comes when it's not an e or an ln or a 10 as the base. So they look like this. It says rewrite as a ratio of common or natural logs, then evaluate and round to 4 decimal places. So the common log is log base 10, and the natural log is ln or log base e. That's what that means. So the first thing we want to do is rewrite as that ratio of common or natural logs. So if it's log base 4 of 25, which number goes in the top? 25. So this would be log of 25 over log of 4. That would be my ratio of common logs. Or it'd be ln 25 over ln 4. Both of these will give you the same answer in your calculator, if you do it right. Should be 2.3219 because it said 4 decimal places. So again, you can either do ln 25 divided by ln of 4, or you could do log of 25 divided by log of 4. Yep.
I think I did something.
Okay, and then 2, what number's going to go in the top? 12. So this would be log of 12 over log of 2, or ln of 12 over ln of 2. I'd get 3.58496, so that rounds up to 50. Yep.
Could you ever like simplify it? Like put
No,
the top?
no, because you can't simplify just that part. Yep. Good question. Questions? Okay, so if it's a question like that, this would be on Friday's portion because we had to use the calculator to get that. Does that make sense? Okay, I'll tell you as you go. All right, then we deal with the properties of logs. So these are all the things you can do with logs. I can take something that's a product being multiplied together, and I can split it up into 2 logs by changing the product to addition. So if I'm multiplying, it's in the same parentheses, so just one log of a base times of a product. Then I can rewrite that as log of the first one plus log of the second one. Both get the base, so notice you have to carry the base over. Whatever that base is has to be on both logs. If it's division, so it's u over v, then when I split it, it becomes subtraction. And the last one is if I have a power, if I'm raising a log to a power, then I can actually bump that power forward and make it multiplication. So if you think about why this happens, logs are basically just exponents written in a different way, right? So if I was to multiply, let's say I have like x to the third times x to the second. If I was to multiply 2 exponential expressions, what do I do with their exponents? I add them. So this becomes x to the 5th, I add. So multiply becomes add. When I divide, so if I have if I have x to the 5th over x to the 2nd, what do I do with those exponents? Subtract. So this would become x to the 3rd. So division becomes subtraction. And if I'm raising a power to a power, so let's say it's x to the 3rd raised to the 2nd, what do I do with the exponents? Multiply. So raising to a power becomes multiplication. So if you're ever questioning yourself as to like what you're supposed to do when, hopefully we practice this so much it becomes second nature, but if you're ever questioning yourself what you're supposed to do when, it goes back to the rules of exponents. When we multiply, we add. When we divide, we subtract. And when we raise to a power, we multiply. Now all of this goes the other way too. So if I start with an addition statement and I want to condense it down to 1 log, I would multiply them. If I start with a subtraction statement and I want to condense it down to 1 log, I divide it. And if I started with something being multiplied on the front and I wanted to condense it, it becomes the exponent. So we're going to flip-flop both ways here. Condense and expand is the wording that they're going to use. Condense means your question already has multiple logs on it and you want to get it to one log. Expand means you have one log and you want to get it out into multiple logs. Yeah.
Do you always subtract the denominator from the numerator?
Yes. Good question. Yep, that order goes. So top minus bottom. Yep. If it's a whole number, do you have to split it up? What do you mean? Yeah. Oh, if you can, then yes. If when you split it, it will simplify, then yes. When we get there, I'll show you what that means. Huh? Right, but only if it could actually simplify. So if the factors would be this power of the base. I'll show you what that, yeah. Don't confuse it yet. All right, so we start with the words like find the exact value, expand. All of these kind of mean the same things, okay? Well, let's start with the first one. The exact value is a little different. This is in log form. So now there's going to be multiple ways to see it. And I'm not going to tell you which way is right, which way is wrong because your brain works differently, okay? But one way to see this is I can take this and I can put it into exponential. So if I want to convert from log into exponential, how does it change my statement? What picks up what? This 5 comes over and picks up the x. So I'd get 5 to the x equals the cube root of 5. What's the cube root in exponent form? 1 over 3. So this is really 5 to the x equals 5 to the 1/3. And then the bases are the same, so x is 1/3. So that's one way to do it, and that's completely right. Another way to do it is rewrite it while it's here. So we just said what it would what would be the cube root of 5? 5 to the 1/3. When we expand, what do we do with an exponent? Put it to the front. So if I push this to the front, it would be 1/3 times log base 5 of 5 equals x. What is log base 5 of 5? 1. 1/3 times 1 equals x, and x equals 1/3. Completely different way to do it, but it gets you the same answer. However your brain sees it, do it.
On the test, are you gonna force?
Nope. It'll just say solve or solve for x. Yep. And notice we didn't need a calculator. This would be like on next week's part. All right, now we get into the actual instructions that say expand, which means I'm going to break these apart. Each of these only have one log because sometimes it's going to say expand or condense, and you've got to know what it means. If there's one log, I'm going to expand it out to multiple logs. If my expression had multiple logs, I'm be condensing it down to one, okay? So expand means I'm going to separate this out. This is a product, right? That's 5 times x to the 3rd times y. So when I expand it, what's going to happen? Good. So this is going to be log 4 of 5 plus log 4 of x to the 3rd plus log 4 of y. So 3 things being multiplied together means it gets separated into 3 expressions and the sum between them. You see anything else there that you can expand upon? What happens with exponents? We bump them to the front. So this becomes log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. Now, when you have logs that have only numerical values, like this one here, it's just log base 4 of 5, you want to see if you can simplify that. Is there something I can raise 4 to get to 5? No, so it stays this way. If that had said, when I broke it apart, log base 4 of 16, now I'm going to update it and make it 2. Does that make sense? So if you can change it, which is kind of your question before, if it's not a power of it, but it's a product of powers, then you can also break it apart. So like if this, I hesitate to do this now because it's going to confuse you now, but let's say it said log base 4 of 20. How could I rewrite 20 so that there's a power of 4 in it? 20 is 4 times 5, right? Does that make sense? That can get broken up. Again, and then this is 1. And then the rest of the statement would be here. So when you expand out and you have just numeric value, no variable in there, you want to look at that expression and say, is there any way I could simplify it? Can I just straight up simplify it? Is there a power I could raise the base u to get to the exponent, to get to the big number? Or can I break it apart into its product? All right, look at 5. Again, back to the word expand. Now it's ln, which is still a log, right? This time I've got division. What does division mean when I expand? Good. So this becomes ln of the square root of 3x minus 5 minus ln of 7. What's the square root in exponential form? 1/2. So this is still an exponent, but it's disguised as a square root. This would be ln of 3x minus 5 to the 1/2 minus ln of 7. And then I can bump the 1/2 to the front. 1/2 ln of 3x minus 5 minus ln of 7. Technically, no, I don't know if I'd mark you wrong if you didn't put the parentheses. Just know if you're going to put that in a calculator, you have to group whatever's here. Let's say I'm checking an answer and I want to plug a value in for x, I have to group that together. Otherwise, your calculator gets rid of this one and does ln of 3x minus 5 minus ln of 7, and it does this part first. Does that make sense? Yeah, okay. All right, 6. Log base 3 of 4x squared over the square root of y. So I've got a couple things happening here. The top, I got a product, and then I also have a subtraction sign for the division bar. So it doesn't matter what order we do this, but let's do log base 3 of 4x squared minus log base 3 of square root y. So the first thing I did was separate out with the subtraction sign. It doesn't have to be the first thing you do, but that's the way my brain goes. Then what else do we see in there? There's an exponent, and there's still a product here, right? This is still a product, so I have to break that into 2. So I'd get log base 3 of 4 plus log base 3 of x squared minus log base 3 of the square root of y, which is really y to what? Good. Log base 3 of 4 is going to stay that way. The 2 here is going to get bumped to the front, and the 1/2 here is going to get bumped to the front. How is this different from log base 3 4x squared? Good. The whole parentheses is squared. So where this results in this, right, only the x has the 2 on the front. The one I just added would be log base 3 of the 2 can go to the front of each. 4 plus 2 log base 3 of x. So I could either split it and then bring the power over, or I could bring the power over first and then split it, but they both get the squared. So make sure you pay attention. Is it in parentheses, is the square on the outside, or is it just applying to one of the terms like the one we did first?
I'm kind of, oh wait, never mind, because I was going to ask why you moved that to the front but not the 4 to the front.
Now you make sense? Okay. Any other questions on expand? Okay. Now we condense. So notice the difference. If I just compare these, because my directions are eventually going to say expand or condense, and you've got to figure out which one to do. All of these have log written more than once, right? And all the ones on the last slide only had log once. So if it's once and we're expanding, that means you're going to end up spreading it apart. In this case, there's multiple logs. We want to condense it down to 1. So we're going to reverse everything. So a 1/2 on the front means what for that x? It becomes the exponent. So this would be log of x to the 1/2. What's log of x to the 1/2? Good. Log square root of x. The 3 comes to the back of here, and I'd get plus log x plus 1 cubed. You do not need to expand and FOIL that out. Now I still have 2 logs. It's either going to be a sum or a difference, right? This one's a what? Sum, which means when I condense it, it becomes multiplication. Log square root x times x plus 1 to the 3rd. And again, technically there should be parentheses around both of those, but you don't need them. But you'd be finding the log of all of that. Yep.
So the square root x and then x plus 1 is the base?
The base would be 10 because it doesn't change. Yeah. All right, go to 8. What's the first thing you want to do? Move the 2 to the exponent. So ln of x plus 2 minus ln of x. This time it's minus, which means division. Ln of x plus 2 divided by x. There is only one ln there, so be careful, yeah.
Why isn't it?
X squared. I even said to do it and didn't do it. Thanks, Bella. Got to bump the exponent, so it would be x plus 2 squared. Questions on that one? All right, 9. This is weird, right? There's like something on the front and then there's brackets. What is that? Why is it on the front and why is there a bracket? What is it telling you? The 1/3 goes to the whole thing. So you can push it now. I can make it 1/3 or I can wait till the end. It doesn't really matter, but I have to condense first before I can take the cube root of it. So I'm going to do what's inside here first, okay? Log base 2 of x plus log base 2 of x plus 1 means what when I condense it? Good. So condense it down to here. Then I can move my exponent. So the exponent goes on the outside. So the whole log base 2 of x times x plus 1 is being raised to the 1/3. And being raised to the 1/3 means what? So this is the cube root of log base 2 of x times x plus 1. So the whole thing is underneath that cube root. You never want to leave an exponent as a fraction. You can keep going.
Did you like simplify the x times x plus 1?
Like FOIL it out? I mean distribute the x?
Yeah.
You can, but you don't need to. So you can save yourself the work. Yeah, you can have made it x squared plus x. That's what you mean? Yeah, but you don't need to. All right, last one. Again, the 2's on the front of all of it. So I'm going to do the inside first and then raise it to the second power. Or you can bump the 2, but you got to do what's inside first either way. So this time it's subtraction, and there's a 2 here. Oops. So this 2 is going to go here. This would be 2 log x plus 3 minus log x minus 2 squared. The minus tells you to do what? Divide. So this is 2 log of x plus 3 over x minus 2 squared. And then the exponent goes to both. So log, you can keep it in the parentheses, x plus 3 over x minus 2 squared squared. Both of them get it. You can leave it like that, or you can go a step further and do log of x plus 3 squared over, and this would be x minus 2 to the 4th. So, I didn't lose a base, right? No. So I would take either answer here. Either leave it with the squared on the outside or distribute the squared. Technically, the second would be more simplified, but I'd take either answer. Was that your question? Yeah. The log doesn't have to be, no. Because the fraction is grouping it. Does that make sense? Yeah. Questions? So the only thing you need your calculator for in this section, obviously, was the change of base thing at the beginning. And then everything else not. But you have to understand these properties before we get into solving equations, which is tomorrow. Do we have any questions on the stuff you covered while I was gone? Like any of the homeworks from the graphing or the logs? All right, so the first thing you want to do is change it so that it's y, right? Y equals, and ln I changed to log base e. Log base e of x minus 1. Because it's graphing a log, we convert it to exponential. So the e comes over and picks up the y. This would drop off, leaves me x minus 1. That's so hard to read, sorry. And then add the 1. E to the y plus 1 equals x is what I'm going to plug into. Because it's a log, I plug into the y. So I would get e to the negative 1 plus 1, e to the 0 plus 1, and e to the first plus 1. So e to the negative 1 is 0.367 plus 1 is 1.3, well, it's 3.6, so we're going to do 1.4 because you're not going to get more accurate than that on your graph. E to the 0 would be 1 plus 1, that's 2. E to the first is 2.7 plus 1, so 3.7. You want to pull in a coordinate grid. So 1.4 negative 1 is here. 2, 0 is here. 3.71 would be here. With logs, we have vertical asymptotes. And the vertical asymptotes comes from the parentheses here. So if I set that equal to 0, I get x equals 1. That means I have a vertical asymptote at 1. And then my curve goes along the asymptote up and to the right like that. Sophia. Yeah, so, wait, did that answer your question though, Nushi? Yeah, okay. And remember, like, again, this would be on, because it won't be an ln graph, to be honest. It would be something that you don't have to use a calculator for. If it's a log graph, it's going to ask you domain, it's going to ask you range, it's going to ask you x-intercept, and it's going to ask you vertical asymptote. It'll have all those parts. But because it's not calculator based, it won't be an E. Sophie, go ahead.
Can I give you 5.2b?
Yeah, anything you want.
Can you do y equals negative log 2x plus 5?
Is it like this, 2x plus 5?
Oh, no, the 2's on the bottom and then 5's. The 2's.
2 is the base, x plus 5 is like this. Yeah? And graphing?
No, it's just x and then a plus 5.
Okay, so that's the vertical shift.
It says for the domain, the x-intercepts, vertical asymptote.
Okay. Okay, so again, we're going to get into exponential, but before you can do exponential, this has to be completely by itself, which means we have to move the 5 and the negative. So I can either multiply everything by negative 1 now, or I can subtract the 5 and then divide by negative 2, or negative 1. So it changes both my signs. It becomes negative y plus 5 equals log base 2 of x. So that, the log has to be the only thing on that side before I can convert it. Now the 2 comes over and picks up that whole thing as my exponent. 2 to the negative y plus 5 equals, this drops off x. And that's what I'm going to plug into. So 2 to the negative 1 plus 5, 2 to the negative 0 plus 5, and 2 to the negative 1 plus 5. So that becomes 2 to the 6th, 2 to the 5th, and 2 to the 4th. So this is like a shift up, big shift up, right? It's like up 5 places. So you're going to get very big numbers because everything got shifted up 5. So if you want to plug in more values, you can. Like this I know is, so we're going to go 16, 32, 64. Pull in a graph. So you're all the way up here, you're all the way up here, you're all the way up here. All those points are going to be way up there. If you want to get more of a curve, then you could continue to plug in. So notice they're getting smaller. Like if I wanted to keep going, so this was my 64, this is my 32, this is my 16. I could plug in like, if I did 3, I'm still getting 2 to the negative 3 plus 5. I'm still getting 2 to the second, which is 4. But that's the first one that's like actually on my graph down here. If I went again and said 4, now I get 2 to the negative 4 plus 5, that's 2. 4, 3, 2, 4. So that's where you're kind of getting more of your curve. I know it's going to come, like it's hard to see because the curve would be like this. But it's doing that. And it's doing it because it's upside down. The negative on the front flips it upside down, right? You have a vertical asymptote. I should have pushed this over a little bit more. But because of this, x would equal 0. That's my vertical asymptote. So it's still, this is so hard because I made this too small. Oh, I plotted that wrong. These are over here. -64 would be all the way over here. -1. 32, 0. 16, 1. And then 4, 3, 2, 4. So your curve is happening all the way over here. There's a vertical asymptote at 0. My x-intercept is where y is 0, so it would be 32, 0. Your domain is from the x, right? So it's from your vertical asymptote, so it's 0 to positive infinity, and then like we got the vertical asymptote at 0. So I would say that one's hard just because there's a big shift, right? Like everything that's normally happening at 1 is shifted up 5 places, so everything gets shifted up. If you see that start to happen, if the points are too big, just continue to plug in points, but pay attention to the direction of the numbers, right? They were getting smaller, so I don't want to plug in negatives. I want to plug in something that's bigger. You're welcome. Yeah.
X equals 3, and log base 3, 8 is like the same power. Like it's raised to log base 3.
Oh, 3 log base 3, 8, like that?
Yeah.
Equals x. Okay. So this is an exponential function, right? If you want to convert it to log, there's a log in the exponent, but technically that's an exponent. So this becomes the base. It would be log base 3. Then they separate. Of x equals log base 3 of 8. So this is my log properties with 1 to 1. X is equal to 8. So ignore if it would, let's just say it was that, right? If I want to convert this to log, I do log, the 3 becomes the base, because it's the base on the exponential function to be the base on the log. And then the pairs never stay together, so they separate out. So you're doing the same thing. This is the base, so it's log base 3. They separate out, so these don't stay together. The log base 3 of 8 goes to the other side, and then the one on the other side comes with the initial one. So the trick, though, the shortcut is to see if the base on the exponential function is the same as the base on the log, you literally can disregard them and keep what's next to it. So if it said 5 log base 5 of 7, my answer is just 7. Long way around would be make that log the base, or the 5 the base on the log, so log base 5. This part jumps to the other side of the equal sign. And then the 7 comes on the side with the log. So then the 1-to-1 property says these are the same, which means x equals 7. I think those are the most confusing because they look like they're logs because the word log is in them, but the word log is in the exponent, so it's an exponential function. It's just being raised to a log.
Can you not do log with a negative?
You can't find the log of a negative number. Right. So if you got log base 5 of -1, that's no solution.
Oh, okay, because
Yep.
I got that on the website.
Oh yeah, no, you can't find the log of a negative number or 0. There's nothing you can raise a whole number to make the answer be 0. So log base 5 of 0 will also be no solution.
Okay.
Yeah. We'll talk about that more tomorrow when we get into solving equations too.
Y equals log base 2 and then x minus 1 in parentheses.
This is graphing, right?
It's domain x-intercepts.
Yeah.
Asymptote, and then graph. And then it's +3.
Sure. Plus 3 is over here?
Yeah.
Yeah, okay. So I gotta move the 3 before I can convert it. So it becomes y minus 3 equals log base 2 of x minus 1. Then the 2 picks up that. So that whole thing is the exponent on the 2. And then I would add the 1 at the end. So 2 to the y minus 3 plus 1 equals x is what I'm plugging into. Yeah. It's like the opposite of graphing with y because we flip-flop it, right? We do everything for the x that we normally do for the y. So then I would plug in x, y. This goes into the y. Negative 1, 0, 1. 2, negative 1 minus 3 plus 1. 2, negative, or 0, minus 3 plus 1. And 2 to the first minus 3 plus 1. This would be 1/16 plus 1, or 1 and 1/16. This is going to be 2 to the negative third plus 1, or 1/8 plus 1. And this is going to be 2 to the negative second plus 1, 1/4 plus 1. Oops, positive. 1 and 1/4. So you're going to have a hard time getting that full curve, which tells me I'm going to probably have to plug in extra points. But I'll do these. So 1 and 1/16 and negative 1 is like right there. 1 and 1/8 is 0. And 1 and 1/4 is 1. So if I were to continue to plug in points, I'd have to plug them into the right. Like I could plug in, I could jump. Let's do 3, right? 2 to the 3 minus 3 plus 1 would be 2 to the 0 plus 1, or 2. So at least I'm going 2, 3. And now I know my vertical asymptote is at, set this equal to 0. Hey, set this equal to 0. It's at x equals 1. And my curve is going like this direction. So x-intercept domain would be 1 to positive infinity. It's based off that horizontal shift, same thing. X-intercept comes from the middle point where I plugged 0 in for y, so that's be 1 and 1/8, 0. And then the graph. You're welcome. Any other questions from the homeworks? We will do more practice on the graphing for sure. The other classes didn't even learn the graphing yet. Like they flip-flop things around while I was gone. So you'll get, I mean, we're kind of on the same page today, but you will get more graphing after the calculator part.